I didn't have any motorcycle projects to work on right now, even though there's plenty of motorcycles sitting around. I was trying to come up with something to do, and I was thinking, who doesn't love a go-kart build? So I searched around on Craigslist and Facebook Marketplace, and I found this. It has a steering wheel that says Rob Ron on it, which was a guy that bought patterns from Rupp, which was a company that raced karts, a guy that built racing karts in the late 50s and 60s through like 74. And this guy bought his jigs and everything, and then he made racing karts. But this is clearly not a racing kart. This is a play kart. It doesn't have the two-stroke motor mounts. It doesn't have a drop axle. It sits kind of high. But it does say Rob Ron on it. Could be made by him, maybe not. I put pictures of it on the Vintage Karting forum on Facebook, and they said it's not a Rob Ron kart. Some guys thought it was a Manco, so I put pictures of it on the Manco forum on Facebook, and those guys said it's not a Manco. All but one who posted a picture of a trike and said that this was that, but I'm pretty sure this got 4 wheels on it, so I don't think it's a trike. It does have some nice features. It's got kingpin inclination built into this straight axle, which is basically, instead of the kingpins being straight up and down, they're slightly angled. The idea being that the angle of the kingpin will run approximately through the center line of the tire when the tire is mounted. That helps improve the steering, makes it a little bit lighter, changes the scrub so the tire is not scrubbing against the pavement. It also has caster, which you probably see, so the kingpins are angled back slightly. That helps with tracking. That makes it track better. If you ever were to autocross your car, you'll especially if you got a stocker, you'll take the struts and push them back as far as you can in the mouse, give yourself a little more caster, make the thing track straight. It does have a 4-stroke motor mount in the back, which we may have to move because I've also got this is a torque converter. I got one of these for it. I may not have enough room to mount it on this side with the motor. I may have to move the motor plate over. I've got this Rob Ron steering wheel is kind of neat, but I got one of these because I think these are even cooler. This actually is a Speedway 12-inch wheel. I like to look at that a lot. I have new steering shaft, brand new 1-inch axle because this thing will have an axle on it. I've also got pairings and all kinds of stuff. We've got new tires. These are Vevor tires and wheels that come mounted on these aluminum rims. You can get these a lot of places online, and you can get them from Amazon, which is where I got these. You can get them from eBay. There's some other places, probably like OMB or something like that's probably selling them. They're pretty nice. They call them rain tires. They got a nice little tread pattern on them. Like I said, I got these through Amazon, and they recommended hubs. These hubs. The problem with these hubs is they do not fit these wheels, which is what I get for trusting Amazon when they made a recommendation that this part goes with this part. So the front and rears, the problem is this is too large a diameter. This is 44 millimeters. This hole is 40 millimeters. The other issue is the bolt circle is not correct. This is an American hub size. These are European hubs. So the bolt circle is 58 millimeters. It's 3-bolt hubs. And like I said, this hole is 40 millimeters and this hub center is 44 millimeters. So I could have returned them, but I looked around and nobody had any Euro hubs in stock that were not like $60 a piece. So, and these things were $30 a pair. So what we're going to do is put them on the lathe and machine down the hub center to fit these hubs, and then re-drill them to bolt to these hubs. And hopefully the re-drilling is going to be very close. I don't have a lot to work with here. I may have to get someone to, with a TIG welder, fill in these bolt holes and then machine it flat and then re-drill it. We're going to take a crack at it and see what we can do. And then we'll also go through the whole process. The motor, I got a brand new Predator engine. It's going to go ahead and get at least a stage 2 kit, so we'll go through that, taking it down, pulling out the governors, sealing up all the holes, get rid of the oil sensor. Probably maybe put a cam in it, probably not. But we might do that, but we're going to go ahead and put a Mikuni carburetor on it, straight exhaust. We might do a little minor port work to it, might put bigger valve springs in it, and see what kind of performance we can get out of that. And then I also have a disc brake set up. This is a hydraulic disc brake for a Honda 450. So the rear brake, and we're going to see what we can do about mounting this brake onto this setup, which is going to involve some fabrication too, because this thing does not have a mount anywhere for this brake. All right, and the next step is going to be machine the hubs down. All right, I'll tell you straight up, I am not very good at this. I've had this lathe for about 8 months. It's a nice lathe. This is a Shopfox M1049. It is a decent size lathe. It will do about 12 by 22 inches. You can thread with it. It does not have power cross cut, but it will power thread. It's a pretty decent little lathe. I made one change to it. This is a quick release tool adapter, which lets me change my tools out faster. And usually I run this little 3-jaw chuck, which is fantastic. The problem is this 3-jaw chuck does not open up enough to fit one of these hubs, because I got to put it on this large diameter right here. It doesn't open up far enough. I can fit it in, take a bearing out, and fit the chuck into this and tighten it, but it's not very straight. So we're going to go with the 4-jaw chuck instead and get it set up, which I cheated. I already did it. I used this as just a dial indicator. Put your dial indicator on your workpiece, lock the magnet, and what you're going to do is rotate this thing, see where you're out on your dial indicator, which you can't see because it's facing backwards, but see what you're going to, where you're out. You turn around, you can kind of see. Lock it back down here so it doesn't fall on the floor. And the thing is out around, it's moving this needle gauge, so you can see where you're out around. And then in the case of this 4-jaw chuck, you've got 4 adjustment points, one for each jaw, and you're just going to shift the piece until it's centered, and then you can make your cuts. Watch me, I'll just drop that on the floor. The magnet hides it, something else out of the way. Alright, so now I'm going to set up our tool here, get it lined back up straight, tighten it up. I know people comment, I am no expert at this, I'll tell you that right now. Bring our thing in, bring our feed back, and I need to, this thing measures, my marks are are inch, and I'm mixing metric and standard, but you know, do what you can. So I'm going to zero this out. Basically what I'm going to do is just, I'm going to make a cut and measure, and make a cut and measure. And actually I'm going to make a couple of cuts before I make my first measurement, because I know I got to take off about 2 millimeters. So I make sure everything's out of the way. I'm going to back this up just a little bit, turn it on. Alright. Okay. You might notice, if you notice a tiny little bit of wiggle in this, these are CNC machine parts. They must have turned out 10,000 of them. They are not 100% straight themselves. But this is, you know, close enough for government work or for go-kart building. So turn that on, bring it in, and we could power feed. We're just going to cut by hand because we're just taking some initial cuts. And you see, not getting a very good chip there. I probably need to turn my speed up a little bit. But I'm lazy and I'm not going to. getting a lot of nice curls instead of nice chips. Alright, we'll shut it off for just a second. And then we're just going to measure it with a micrometer. As soon as we get it to 0. Make our micrometer measurement. And we're at 42.8, down from 44. So we still got a little ways to go. So we're going to give us another 10 here. So another 10. Turn it back on. Go down. And we got to be careful because we don't want to overcut it because you can't go back. Once you cut it off, you can't stick it back on. So I think this is going to be my final, not my final cut, but the final time I do it. That's being really careful about how much I cut. Shut off again. So we're at gauge. Let's make another measurement. Okay, probably got about 2 more cuts. Powered up. If I really knew what I was doing, I could make 1 cut and be done more than likely. But I straight have to admit I don't know what I'm doing. I know just enough not to hurt myself. And now we're power feeding, no hands. Alright. We'll get a much better cut with that power feed. Go back and measure this again. We're at like 41 millimeters now, 41.1. Alright. Up. Let's give it another 5. Now this is probably super boring to watch, but you know. Oh man, we're getting super close. I just have to do this 4 times and I'll have my hubs to the right size and I can drill those holes. Hopefully it looks like I got enough material. I believe I have enough material to do this, so I really got my hopes up that this works. Aside from it being 60 bucks down the drain for these parts, but I'm pretty sure that I can get this to work. Oh, almost went a little too far. All right, let's see where we're at now. Oh man, I'm gonna do 1 super light cut, and we should be there. All right, let's about. Okay. What's gonna be really funny is I'm gonna take this thing off and it's gonna be still too big to fit inside the hub, and then I'm gonna have to set it up again, and I'm gonna be highly annoyed with myself. So yeah, we're gonna have to do. Oh, we gotta do another one. I'm trying to get it right at 40 millimeters. Let's see what we can do here. And of course, these little mini lathes are fantastic. If you like to tinker on stuff around the house, I've made all kinds of, or did I say around the house? You want to tinker on stuff around the shop, they're great. I've made little parts for bicycles and motorcycles and all that kind of stuff. They can be super handy. They're not crazy expensive. This is one of the bigger small lathes. You can get a micro lathe, which is more easily speed adjustable than this one. You can pick those things up for a couple $100. This is I think about $1,000 lathe, and We're going to get and worth every penny. Last one, seriously, this is it. This really is it. Last time. All right. Well, 100% certain. This is going to be the one. This is going to be the one. Oh yeah, right there. All right, like 39.9. So we just need to take this out. Always remember, don't ever leave your tool in the lathe when you're done, and you forget to fire it up. It will shoot the rascal right across the shop. Okay. It will scare the crap out of you. There we go. Hub's done. Now, will it fit? All right, let's see if it fits. Look at that, right in there. You can see if you look close, we can get in there close. You can see that we don't have a whole lot of room here with the holes. We got that one little spot right there where we can drill and put the studs in and have a way to bolt this thing up. Hopefully we don't have to do any welding and refacing, but we'll see what happens. Also, I realized I left a step out. I should have chamfered this edge when while I still had it in the lathe. And so now I got to reset it and re-zero it and then chamfer that little lip, which will, one thing, it's sharp, and watch me slice my finger open, it's sharp, but the other issue is it'll make it a little easier when you put the wheel on. It's not going to catch on this sharp edge. Okay, just to show what I would do to put a chamfer on it, I got it centered up back in there. There's two things you could do. You could turn it on and take a file and carefully put the file on here and take the edge off, which is actually not a bad way to just take the sharp edge off of something when you don't want to chamfer. The other thing we can do, which is what we're going to do right here, you could do like a crazy setup and cross slide this thing and put an angle in it, but what we're going to do is just loosen the tool up, turn the tool at a bit of an angle to the workpiece and back it up just a little bit. Alright, and we've got a little bit of angle there, and on the cutting head we have a little bit of angle. We're just going to tighten this thing up and cut it on, and then push the workpiece, push the tool into the workpiece, and just put a little edge on it like that. And that's it. And then I'm going to do this to the other three pieces and we'll be done. Alright, I have all the hubs machined down. I have not drilled the holes yet, but I couldn't wait. I had to stick an axle on there and take a look at it, see what it looks like. See, because this is a, whatever you want to call it, resto mod or something like that. This is for fun. So I wanted to have a look. I love these wide tires. I'll probably space them out wider. I think the width is like 35 inches. I'm space them out a little bit wider than that. You can see this thing's got a steel pan and seat, which is pretty rusty. So that's going to come off. I'm going to replace that with aluminum sheet, tab the frame for aluminum, put that on there. But it looks pretty good. I like these fat meats on here. I wanted the cart to sit as low as possible, but I also have to be realistic about it because it's still going to be a play cart, so it can't be right on the ground because it's probably going to be ridden off pavement some. So I think I had originally thought about dropping the axle, but this thing actually has dropped spindles on it. You can see the spindles are actually pretty high on the kingpin. So I think I'm going to leave it alone, although I am going to replace those spindles because the way this piece is not welded 90 degrees to the spindle, it actually contacts here before you get a whole lot of lock. So I'm going to do them at 90 degrees so I can get a little more steering lock. And of course they welded all this on, so this is going to have to be cut off and new steering shaft and everything. But it looks pretty good. I'm pretty happy with this. Okay, now we need to center punch the 3 new holes we're going to put in this hub. So what we're going to do is I got a piece of, this is a 1-inch aluminum pipe, or not pipe, solid stock, aluminum stock. I have clamped the hub to it. I'm going to put the rim on it like this. We're going to turn it till we get it lined up and like that. And you can actually see I've already got holes punched in this one because I had to try it out real quick. And what I did was I took a piece of stock and so I can get it in focus. I took a piece of stock and just laid it down till it fit the hole correctly, and then I put a little nib right on the end of it there so that when I tap it with a hammer, it puts a little punch mark right in the center of the hole, right where I need it. So now I've done that, I just have to do it with the other 3, and then we'll drill them out and tap them. Alright. To do the front hubs, I had to get a little more creative. This is a piece of Delrin that I just cut down to fit inside the bearing, and the hub will just fit right on top of it like that. And then you can slide also junk out of the way. So you'll get that lined up right there. That sits down right there. And then the only hard part is, to do it with one hand anyway, is we'll get the holes lined up, or get it lined up so that we're in between the holes like that. And then we will use our little piece again, stick it right in here and give it a tap, each one of them, and then we'll have our 3 holes marked, and we can put it in the press and drill them out. Success! Got all the wheels on, we got the studs and the bolts in. I don't have any nuts yet for the axles, but that's okay. In the back side, there wasn't quite enough clearance for the heads of the bolts, so I ended up cutting, like you can hardly even see in there. There we go. So I ended up cutting the heads off, flaring them just a little bit, and put them in with red Loctite, which, if my previous experiences with red Loctite is any indication, they should stay there forever. They'll probably break the hub trying to get them off, but since I need them to stay in there, they will probably fall out on their own. You can see I've got some string right here holding the wheels together because I don't have any tie rods yet. I'm going to make a set of those, and that'll be another project.